So this is one example of an application of a sinusoidal function in the typical Ferris wheel, but it could be anything that's cyclic, like tide levels or sunrise, sunset, that kind of thing. So let's take a look. So the height of a point on a Ferris wheel above ground as a function of time t in seconds can be represented by a sinusoidal function. Now, just to note, sinusoidal doesn't mean it has to be a sine function. It could be a sine or a cos function, okay? Then, the maximum height of the Ferris wheel above the ground is 21 meters. That's going to be important later. And the minimum height is 1 meter. It takes 30 seconds to make 2 revolutions. And we want to figure out the equation of the sinusoidal function. Okay, so first of all, you want to graph this so that you can get some characteristics of it, like amplitude and all that stuff. I find when you're looking at it, it's a lot easier to determine that. So when they said represent height as a function of time, you want to label your axes. So height in meters, and this would be time in seconds. Okay, now on the height axes, the maximum and the minimum that they gave you is very important. And don't worry about scaling that axis, it's not important. So we'll just write in the maximum height, which was 21, and the minimum height, which was 1 meter. Okay, now for time along the seconds, let's say we want to plot 2 cycles. It said it takes 30 seconds to make 2 revolutions, which means it would take 15 seconds for 1 revolution. And guess what? 1 revolution is the period. So we right away know our period is going to be 15 seconds. Okay, now we're going to come back to that. But along our axes now, if we want to graph, say, 2 revolutions, we're going to go 15 and 30 and try and space that out a little bit so it looks approximately the same space. And now we're going to plot our points. It didn't say where the points started, but usually they start from the bottom because that's where the rider gets on. So we're going to go with that assumption. So we're going to put a point down at 1 meter, and after 15 seconds, we know it's gone around 1 complete time. So that point would show up there again. And after 30, and then halfway in between, which I guess would be 7.5 seconds, it would be up at the top. And there we go. Same thing here. And now we can draw our sinusoidal function, kind of like that. Okay, from there, we'll be able to get our amplitude, which is the max minus the min divided by 2. Okay, so that's going to be 21 minus 1 divided by 2, which is going to be 10. We can get our vertical displacement. I like to do that one next because it's the midline basically, and it's very similar to amplitude. It will be max plus min divided by 2. So 21 plus 1 divided by 2, and that's going to be 11. Okay, so that midline is happening at 11. We know our period already, but we need our b value for the equation. So b is equal to 2 pi. We usually work in radians on these with these application questions. So 2 pi over the period, which is equal to 15, and there we go. And then finally we need our phase shift. So our phase shift is going to be horizontal phase shift. It depends on what type of function we choose. But typically with these ones, rather than finding the midpoint as we go up, that would be the point we'd be looking for sine. It's sometimes easier just to find the peak, which is what we need for cos. So the peak we know is happening at 7.5, halfway to 15. So that's going to be our phase shift, is going to be 7.5 to the right. Okay, now we sub everything into our equation. I'll just write it out with all the variables first. X minus c plus d. And now subbing in our amplitude, which is a essentially, unless we make it negative, but we'll leave it positive, is 10. And then cos, our b value was 2 pi over 15. And yes, it is weird on these application questions. And then we have x minus our phase shift, which is 7.5. If it had been moved left, it would have been plus 7.5. And then plus our d value, vertical displacement, which is 11. And there you go. That would be our equation. Now, if they ask any other questions, like when is the height at, say, 10 meters, so they're giving you y and asking for x, you're going to want to graph it and put this into y1 and say the 10 meters into y2 and find out where they cross. If they are asking for the height at a certain time, again, you can graph it or you can just simply put it straight into the equation in the calculator. Okay, hope that helps.